Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I are working on a JVM, and this time we're going to add support for integers beyond the range that a short can hold, and judging by past experience that will probably cause us to make other changes, and we'll see what happens. Okay, the next thing I wanted to do here is make sure we support even larger integers, right? We tried a value of 300 last time and that was fine, but we need to do one that will not fit in a short. So let's run this. And I'm sure we'll have a new opcode that requires us to push an integer. Oh, so this is an unknown constant type 3. All right, this is an integer constant. So this is going to be in the constant pool. And we need a new type for that. This is basically 4 bytes. And we should be able to read that probably with our data input stream. So this is actually going to be in the parser that we need to take care of this. Here we go. Handle that. I guess we don't need a method for this, just say new integer const, I guess. Is that what we called these? Yeah, string constant, so integer constant. And it'll be 4 will be the value. So we need a new type here. We were making these all public, weren't we? I guess I could have a constructor here just to make it easier to initialize. And we should be good to go in that respect, but I guess our code isn't going to run and it's not going to work the way I expected. Okay, so we got an unknown opcode again, which is not really surprising. That's coming from our translator. Let's put a 0x here just so I never forget that's in hex. So it's 0x12. Okay, so this is a load a constant. So we've got a load constant and then an index, and that'll be an index into the constant pool. And then we're going to push it onto the stack. All right. I'm trying to decide how generally we want to solve this. We could sort of hard code it for the integer constant we're dealing with, but we really need to be able to push any type of constant. Okay, so hex 12 is a LDC, and then the next thing in the code is the index. So let's handle that. And we need to read, is it a byte? What was the type for the constant index? It is a byte, so you can only have 256 constants, huh? So we'll say index is the next thing in the opcodes. You know, this way that I'm incrementing index here, I don't really like it. I think we should be doing it here. So when we get an opcode out of the array, we should increment index here because we just used this byte. And then if we get the next byte, we should do the same thing. So basically use the current index, which is the byte we're looking at, and then increment it to move past it. I think that's a better way of doing this. So this is our index into the constant pool. Oh yeah, we can't use byte index here. And then we're going to add a new opcode. I guess we'll call it load const. A little more readable than LDC. And if I'm changing the way I'm doing this increment, this won't happen at the end anymore. And the read short should also follow the same pattern. Okay, now we need our load const opcode. This needs a constant index. And a constructor. And we're going to have to update execute. So execute right now has the stack for the current method and the local variables. We're also going to need the constant pool. So right now in our parser, we get a list of constants. I guess that's going to be our constant pool, right? And they're being referenced by index. So we'll be passed a list of constants. And then in here, we're going to push the constant onto the stack. So we're going to say stack. So we can't just say push constant. We're going to have to do different things depending on the type. We could maybe ask the constant for its value and then push that on the stack, but some of those values will not be an integer. They won't fit inside an integer. So we can't really do it that way. When we push references, or I guess longs and doubles at least, are going to be more than 32 bits. So instead, I think we need to have the constant push itself on the stack. So let's do that. Can't call it that. It's const. And then we'll say c.push stack and return 0. Now, the other way that we could have done this is to have the opcode hold on to the right constant. So at translate time, we could look up the constant in the array and give the constant object to this load const opcode. I'm not sure it makes a whole lot of difference. And I guess it's slightly more efficient to do it that way, like a tiny bit. I'm not going to worry about it. Our VM is not going to be fast anyway. All right, so we have a couple of things we did here. We changed the signature for execute, so we need to update all of our opcodes. I wonder if there's a refactoring we can do here. Okay. And now we got to go fix all of these. I guess I can do it this way. Well, okay, so we still have a push that needs to be added to the constant interface. And then we're going to have to implement that for our two constants. Putting a string on the stack pushes a reference onto the stack. I don't really know what a reference is. I think we're going to punt on the string for the moment because we haven't tackled reference types yet. So let's just push a 0 for now. Or maybe a -1. Maybe that is more likely to tip us off that we screwed up. That's okay, isn't it? It's just because constant hadn't been saved yet. So the integer constant, we will go ahead and do a push. The real integer. And I guess we are going to punt for now on some of these other ones. One thing, I don't know what it would mean to push some of these things. All right, so we can theoretically now push an integer onto the stack. Let's see, oh, our build isn't quite right still. Yeah, we're calling execute wrong. So in our engine, we're going to need the constant pool for the method that we're dealing with. And then in JVM, we need to pass it in there. Our parser is really parsing a single class. I guess for now we can pass constants in like this. What's the problem here? Oh, I did it in the wrong order. This opcode, that's weird. Did that just not get saved? What happened there? All right, anyway, our program compiles again. And if we run it now, we are now successfully adding to an int. So we made some significant changes to the translator, and I'd like to test those. Up till now, we've done that manually, but I think it's time to actually write some unit tests so that we don't have to keep trying things over and over, and also so we don't forget about cases that we might want to test. So I grabbed the JUnit jars and put them in the lib folder here. And then I'm going to add a test folder. And then we're going to need to add that to our class path. So down in the Java projects window, there's a button here that lets you choose configure class path. We'll need to add test. As a source folder, and then we'll need to make sure that our JUnit library showed up here. All right, so now I think we can create a test. So we want to test the translator right now. Now, to test the translator, we're going to have to give it the right bytes, and then it will create opcodes. We could check that by looking at the opcodes that were created and checking all of their members to make sure they're correct. But then we would have to add an equals method to every opcode class. That's going to be pretty annoying. It might be better to translate and execute the opcodes and just look at the results. That's probably going to be good enough for what we've done so far, at least. So let's try that. We're going to need a translator. have to give it our code attribute. It's just a code attribute, I guess. We are going to need a new way to create one of these, and we'll have to supply it. We need a way to supply the opcodes directly, I think. I guess maybe all of these things. These are public, so I guess it doesn't really matter much. We just need a default constructor, and then we can assign whatever we want. So let's do that. I guess I have to say supercode. So we can do this, and then we can say code.opcodes, and we can give it our actual opcodes. Now, for adding an integer, we had a handful of opcodes that we needed, right? So we needed a load constant, which is 12. It might be that we want to create constants defined for these, so it'll be easier to do this. We'll wait a minute and see how that goes, but we're loading. This is a constant, and then it's going to be our first constant in our constant pool. So I guess this really belongs on the same line here. And then we are going to do a push of a small constant 1, right, which was an iconst. So this is -1. I think 0x04 should be pushing a 1. And so this is iconst1, I believe. And then we're going to do an add, which is 60. And then we're going to store the result into the constant, or into our local variables. So that's a iStore, and our var index, I guess, just is going to be 0. So 3b is fine. Now we're going to say t.translate. That'll give us some opcodes. And then we need to execute this to test it, basically, for its engine. We have to give it the code. We'll give it our constants. We'll give it our opcodes. I think the code also needs to have its number of local variables set. So max locals is going to be 1 because we do need one of those. We need a constant table. And then we're going to add to it an integer constant. And our value was, I think, 300,000. So we've done our execute, and then we need to get back the local variables. So this is okay. We'll make this public for now. Oops. Maybe we'll make execute return the local variables. Sure. For now, that's fine. Let's do that. And then here we're going to check them to make sure they're what we want. So in this case, we're just going to assert that the length is 1. And then we'll assert the value of the first one is 300. 300,001. All right, let's see what happens. Yes, okay, we forgot our return. We need a return at the end. So that is B1. Can't have a trailing comma. Oh, it's bigger than 127, I guess. Okay. Yeah, that's a little annoying. Okay, the test passed. So we did get this value back. Now we'd like to do this again. We've used the iConst, we've used iAdd, we've used iStore, we used loadConst. We had a bypush and a SciPush that probably need to be tested. So let's add a test for those. Now, we're not going to want to repeat all of this stuff all the time. So let's make a function that will handle this for us. So we're always going to create a code attribute. I think we're going to pass in the opcodes. So we'll take byte array opcodes, and we'll take an int that's the num of locals, and we'll take an int array that is the expected result. So here we'll say code opcodes is the one that was passed in. I guess really, maybe the code attribute should be passed in directly. For now, we'll leave it like this. And then, yeah, we do need constants. Yeah, I guess this should be the code attribute. And we'll have our constants. All right. Don't need this, don't need to do these. We'll do create the translator, translate, run the engine, and then we're going to check the array. I thought there was an assert equals for that. Yeah, okay, assert array equals. All right, so something like this, and we're going to want to do this for every test. Maybe this should be expected locals. So now we create our code attribute and our constants, and then we can call the other functions. So test exec. And this is going to be new int array with 300,001 in it. Okay, so this still passes. So now let's test our bypush. So instead of a load constant here, we're going to want a bypush. And that is 10 hex, and it's followed by the value. So our value could be, I don't know, 32, we'll say. Push. And so 32 plus 1 ought to be 33. And we don't need constants in this example, so we can pass null for this. It should never be used. All right, that passed. And then we'll do the short version. So the SciPush was, I think, 11. And then if we're passing a short, We could do a 1 and a 0. This would be 256. So then we'd expect 257 here. So now that we have these unit tests, we're not going to have to go through and change the code that we're starting with and run it and see if it works manually every time we make changes. Let's make sure we got all of the opcodes that we had built here. iconst, istore. We didn't use iload, I guess. But we used the rest of them. So let's do one with an iload. We can put a couple of constants on the stack. Actually, I guess we'll do, here, we can do this. We don't really even need to add, right? We're going to do a constant one goes on the stack, stored in variable 0. Then we'll do an iload, which was 1a. So this is iload 0. And then we'll do an istore 1. So that would be a 3c. And our number of locals now is 2. And we expect to see 1, 1. All right. Technically, we should have written these tests first and seen them fail and then see them pass. So this is a little weird, right? That everything's passing on the first try. Let's break at least one of them, make sure we're really able to fail here. Okay, so we expected a 1 and we got a 0. That makes sense. Okay, so now we can push various sizes of integer and we can add them, and we've got some unit tests that are keeping us honest. Well, as predicted, adding the ability to handle a larger integer led to some other changes. We needed to add support for constants, but that went pretty smoothly. We've also got unit tests now, so we'll be able to be fairly confident that we're not breaking things going forward. Next time, I think we'll try to add support for floats, and that's probably going to open a whole can of worms. Thanks for watching. Don't forget to like and subscribe.